Welcome you all. Now we are going to see the CDS heuristic, which can be applied for n jobs, m machines problem. Even if the conditions of n job, 3 jobs machine problems are explained in the earlier lecture, even if the condition is not satisfied, this heuristic can be applied. Heuristic means it's a rule of thumb. That means the three scientists, Campbell, Duke and Smith, with their name, the heuristic is named as CDS algorithm. And let us try to solve or understand this heuristic with the aid of some numerical illustration. Now, in this small numerical illustration, we are considering 4 jobs and then 4 machines. Each machine M1, M2, M3, M4 has got the processing time for these jobs 1 to 4. For example, the job 1 has got the 4 hours of processing time in the machine 1, 3 hours in machine 2, 7 hours in machine 3 and 8 hours in machine 4. Similarly, there are 4 jobs, their processing times are given. Now this heuristic is very simple. In this heuristic, we are going to find out the sequence based on the Johnson's algorithm by combining the machines individually as well as combinedly. That means here, in the first table, the first machine and the last machines are considered separately. That means the processing time of the first machine as well as the last machines are considered separately, and then we have found the sequence. That means 4, 3, 1, 3 is the processing time of the first machine, 8, 5, 7, 2 is the processing time of the second machine. Based on this, the sequence is just created 3, 2, 1, 4 based on our Johnson's algorithm. In the next step, what we are doing is we are adding the first machine and second machine and considering as an imaginary machine. Then the last machine and last but one, that is the previous machine, that processing times are combined together and then formed as a second machine, second imaginary machine. The first imaginary machine 4 plus 3 for the first job. The 8 plus 7 is for the second machine. Now we are forming a table. Based on this processing time, we are finding some sequence that comes to 3, 1, 2, 4. Then in the third step, what we are doing is the processing time of first machine, second machine and third machine we are combining together. That means we are just moving ahead. Then last machine, last but one and further before one machine. So all these 3 machines are combined together and then they are forming as an imaginary machine. So in this table we can notice 4 plus 3 plus 7, that is 14 is the processing time for the first job, and then 8 plus 7 plus 3 is 18 hours is the processing time for the second imaginary machine. Likewise, we are forming a table and then we are predicting some sequence based on your Johnson's algorithm, just like your previous method. Now we will be having a different sequences. In this case, we are finding these 2 sequences are similar and this sequence is different. Now for all the sequences, we are going to find out the max span time by providing your scheduling based on the previous lectures. We are just finding the max span time for all the 4 machines. Now for this any one sequence, I am just telling you how I explain how the max span time can be evaluated. For example, let us consider 3, 1, 2, 4. With the 3 machine, the job is assumed to be started at 0 time, and then with the third machine, so 1 hour is the processing time in machine 1. So at 1 hour it will be coming out. At 1 hour it will enter into the machine M2. There it is getting processed for 2 hours. Then it becomes 1 plus 2 is 3. At 3 hours it is entering into the machine M3. There it is getting processed for 4 hours. So at 7 hours it will be coming out. At 7 hours it enters to the machine 4. There it is getting processed for 7 hours. So it is 14 hours it is coming out. As soon as the machine 1 is free after 1 hour, it takes up the next job, that is the first job. There it is getting processed for 4 hours. So at 5 hours, this first job will be coming out of the machine M1. Now, even though it is coming at 5 hours, at 3 hours the machine is free. so that the machine is waiting for 2 hours. At 5 hours only it can take up the next job. That means the first job enters into the machine M2 at 5 hours. There it is processed for 3 hours. So 8 hours it is coming out. So here it can enter to the machine M3 at 8 hours even though it is free by 7 hours. So there it is getting processed for 7 hours. So it is coming out by 15 hours. So at 15 hours it enters into the machine M4. 15 plus 8 is 23. It is coming out from machine M4. Now here at 5 hours the job 2 enters into the machine M1. So there it is getting processed for 3 hours. So it will be coming out by 8 hours. So at 8 hours it can enter into the machine M2. So there it is processed for 7 hours. So it is 15 hours. So at 15 hours it enters into the machine M3. 15 plus 2 is 17. At 17 hours it is coming out. But 22 hours, 23 hours only it will be entering into the machine M4. There it is getting processed for 5 hours. So it is 28. Here at 8 hours it can take up the 4th job. So 8 plus 3 is 11. At 15 hours only it can enter into the machine M2. 15 plus 4 is 19. At 19 hours only it can enter into the machine M3. 19 plus 3 is 22. 28 hours only it can take up. 28 plus 2 is 30. In the same similar way, if we can evaluate this sequence or this sequence one and the same, the maximum time will be 31. Now this sequence gives 30 hours. This sequence giving 31 hours. Among this sequence, that sequence which gives the minimum maximum time is the best sequence. That's what our CDS heuristic suggests. So as per the CDS heuristic, this sequence 3, 1, 2, 4 which gives the minimum maximum time is supposed to be the best sequence. So this is how n jobs m machines. Here the number of jobs are considered as 4, number of machines are considered as 4. So any number of jobs, any number of machines can be considered, and then this heuristic can be effectively applied so to find out your best sequence that minimizes your max span. But whereas if the number of jobs and other number of machines are increasing, the solution space increases exponentially. Under that circumstances, it is very difficult to evaluate all the possible sequences and predict the best sequence. So in that time, the CDS heuristic will be useful in predicting the sequence. Of course, for this one, the combinations are very less.